do like normal. Okay, so please remember that anytime something is squared, that's when you multiply them together. So this is x to the 4. This is z to the 24. And then over there, over here, this is going to be z to the 6. So the reason why I'm bringing that up is because we really need to be good with rooting things. So if you multiply to square it and cube it, then you divide it to root it. So y'all, we're taking the square root right here, and remember that's understood to have an index of 2. So we would just divide. Oh my stars. We're going to lock this little guy, and then I'm going to be able to write a 2 here, like that. So we just divide. By the way, all of these are even exponents. What do you remember about even exponents? They're positive and they're perfect. So if I'm taking a square root of even exponents, I should not have any remainders, which I'm not going to. Just divide. So this is x to the first power, y to the third power. 8 divided by 2 is 4, so z is going to be to the 4th power. Over here, you're still dividing. We're just dividing by 3. Y'all, look at all these exponents. I have an exponent of a 12, a 15, and a 21. Are those all perfect cubes?
No. Yes.
I'm dividing by 3.
Oh, perfect cube.
Perfect cube, yes. Perfect cube, yes. They're all multiples of 3. So no remainders, they're all perfect cubes. So this is going to be x to the 4. What about the y? Just dividing. And then what about that z?
7.
Yeah. Good job. If you know that, today's lesson is going to be pretty easy for you. There's one more thing we're going to talk about before we jump into the packet, and that is going to be this right here. Oh, I don't have this as a color slide. No, I do. You can just barely see it. So this is supposed to be a color slide because it's not in your packet. We're going to pretend that it's red. So on this red slide, we're going to review what perfect cubes are. And most of you guys should know the first one. What's 2 times 2 times 2? Keep going.
27.
Yes?
64.
125. And then here's where I hear crickets, usually.
What? 46. 36 times 6. 1 to 100. Greater than I don't care.
Shame on you. Yes, you do. It is 216.
I'll have a calculator.
216 is your perfect cube for 6 to the 3rd. You should memorize 7 to the 3rd for the next couple of weeks or so. 7 to the 3rd is 343. So do try to knock out memorizing those. And then 10 to the 3rd, y'all, that's just scientific notation. Almost. 3 zeros.
Oh, I was doing, on the PSAT, I was doing, I don't even know. I don't want to talk about it.
Okay, packet. Go to your packet. This is page 4, I believe. Let me confirm page 4. Okay, awesome. So this is going to be the difference in sum of cubes. Sum and difference of cubes are factorable, as long as the first term is a perfect cube and the last term is a perfect cube. So what we're going to do is we're going to look at these rules. To me, this is a lot of symbols and kind of hard to follow. I have a little saying that I'm going to share with you. It's on the board right there. For some reason, stare more. That sounds totally random, but you'll see how it kind of fits into play later. So right here, there's your subtraction. Here is your plus. Notice it is the same format. When it factors, it's always a binomial and a trinomial. So I usually put the binomial first because the binomial drives exactly what the trinomial is. And I'll show you what all of that means. And then there's something called SOAP. I don't really use SOAP because I just kind of analyze the problem, but Miss Nudie and Miss Lisk will probably use that terminology. Just be familiar. It's the signs. It's a little mnemonic for how the acronym for how the signs are in the binomial and in the trinomial. So let's kind of get started. Here's some other examples of how they use that SOAP acronym. The signs are always going to be whatever is from the problem. Notice the last term is always positive. Same sign, opposite sign, always positive. Okay, so here's my silly little saying, for some reason, stare more. And that is just a mnemonic for all of the steps that we have to do. We have 1, 2, 3, 4, 5 steps. The first step to factor the difference or sum of cubes is to, of course, take out a GCF, just like if you were factoring a regular baby trinomial. And then we're going to sign what goes in the binomial and what goes in the trinomial. Then we're going to root it, cube root it, because we're dealing with cubes. Then we got to turn around and square things. That's going to be the ends of the trinomial. And then we're going to multiply the terms of the binomial to be the very last piece of the puzzle. All of that's going to make sense in a minute. Just remember, it is for some reason, stare more. And if you notice, I do have 2 S's in my little acronym or my mnemonic that I use. But what rhymes with the word stare? Square. So I already know what process that is, even though I have 2 S's. Then I'll be sad for you. Okay, so is this number 1 in y'all's packet? Yes. Still page 4. All right, cool. Y'all, this is certainly factorable. X to the third is perfect. 8 is perfect. So do they both share a GCF? They don't on this one. So I don't even have to worry about step 1. All right, step 2 says to sign it. Here we go. Remember, I'm going to draw parentheses for a binomial, so there's a little space in there. Then I'm going to draw another set of parentheses, and I'm going to space it out a little farther because 3 terms always go in the second one. So, for some reason, sum stands for sign it. That means whatever is printed on the problem, whatever sign is printed on the problem, that's what I print first. So what sign was already there? Yeah, so we're just going to, and then if I already did that, then I have to use the other sign. What's the only other sign? A negative. And then remember, that one has to be positive. So factor it, sign it, root it, cube root it. What is x to the third cube rooted? A single x, that's right. What's the cube root of 8? Okay, done looking at the problem. When everything in math, guys, you never look back. So I'm done looking at that. I don't want to look at that anymore. Everything else is driven from that binomial. All right, so we have factored it. There wasn't a GCF. We've signed it. We've cube rooted it. Now we're to squaring it. Look at the first piece of that binomial. What is x squared? That goes here. What's 2 squared? That goes here. And that's that step. It's the ends of the trinomial. And then the last step is to multiply from the middle. Guys, what's 2 times that? That's it. We're done. That just goes in the middle. Your trinomial cannot be taken any farther. You do need to sometimes check your binomial, though. Sometimes the binomial can be factored further. This one cannot. So we're ready to just box this in and take a look at what the next problem is. Okay, so on this one, we just have variables, same process though. So we're going to factor it, sign it, root it, square it, multiply it, and then keep going. Since there's just variables, there's no GCF, so I'm done with this. Let's sign it. Let's draw some parentheses for a binomial. Draw some parentheses for a trinomial. And then, y'all, what sign is printed on the problem? A negative, so the minus goes first. And if I've used a minus, the only other thing available to me is a plus. And then remember, the last one's always positive. Okay, let's cube root, y'all. What is 6 divided by 3? So you just cube rooted the first term. Y has an exponent of 9. What's 9 divided by 3? That's the next term. Done. Remember, you don't look back. Don't look at that problem. We're done with the original problem. Okay, so let's square it. What's going to be my first term of my trinomial? Awesome. Last term. Very good. Y to the 6. And then for the middle term, we just stick them together. So the middle term is x squared y cubed. And then that's all I can do. I can't do anything with this right here. There's no such thing as factoring a difference of a cube and a square. Oh, I'm sorry. What should that be? Thank you. Yeah, don't mess with those exponents in that binomial for the middle term. We're just going to leave it like that. Okay, let's take a look at the next problem. I don't think there's anything here. I might have had a plus sign instead of the next one. Here's the next one. So for the next one, we have 8x cubed plus 1/8. That is certainly a sum of 2 cubes. Make that just a little smaller. Okay. There is not a GCF, y'all. I can't take out an 8. Because one of them is a whole number 8, the other one's a fraction of 1. So there's not a GCF. So there's really not step 1 for us here. But we can sign it. So draw a binomial and then a trinomial. And then what kind of sign goes in the binomial? Plus. So that drives everything else. What's the first term of the binomial? 2x. Good. What about the other term of the binomial? Yeah. Now listen. We're done with that. So we rooted it. Done. Y'all, we're about to square it. Remember, you have to square the whole entire thing. So the first term of my trinomial is not 2x squared. What is it?
4.
Yeah, you got to multiply, you got to square that coefficient also. And then what's the other bookend? What's the end? 1/4. So we're going to multiply them together. That's 2x times a half. What? 2x times a half? It's just an x. Can anything else be factored from that? It cannot. So let's box that in. Okay. So by just glancing at this, I don't think this is factorable because 2 is not a perfect square. But it is factorable. How come? GCF. Good job. I used to always overlook the GCF, so don't be like me. Make sure you always find those and factor that out. So we're going to factor a 2 out. And then what do you know? It's factorable. You have a difference of 2 cubes. So we factored out a GCF. Let's go ahead and set up our signs. So minus, plus, plus.